Today we're going to be looking at how to solve real-life problems involving right triangles and directional bearings. Let's look at the first one using our right triangle. From a point 100 feet in front of a public library, the angles of elevation to the base of the flagpole and to the top of the flagpole are 28 degrees and 39 degrees and 45 minutes respectively. The flagpole is mounted at the front of the library's roof. So we want to label all the unknown information and parts of the diagram, and we want to find what the height of the pole is. So we want to find this. So what we're going to do is we're going to use the idea of right triangles to find what the height of the building and the height of the building plus the flagpole. So let's look at the height of the building first. Okay, we know that our angle of elevation is 28 degrees. We know the distance from this point right here where we're standing all the way to this point right here is 100 feet. And what we want to do is we want to find the height of the building, so let's call it x. So we're going to look at the relationship between the x and 100. We see that it's the opposite and adjacent side, so we're going to use tangent. So tangent of 28 degrees is equal to our opposite x over our adjacent, so 100. So what we want to do is we want to solve for x multiplied by 100 on both sides. So we want to find 100 times the tangent of 28 degrees, and that's going to give us x. We put it into the calculator, and what we're going to find is that x is going to be equal to 53.17 feet. We want to do the same thing now in order to find how tall the building is with the flagpole. So we're going to make our new triangle. So remember, this one has the flagpole now at the top. Okay. So we know that we have the angle that's given is 39 degrees and 45 minutes. And once again, it's the same distance. It's going to be 100. But now we know it's a different height, so let's call it y. Once again, we see they're related by the tangent. So the tangent, and we want to convert our 39 degrees and 45 minutes into a decimal, so 39.75 is equal to our opposite, y over our adjacent. We want to solve for y, which is the height of the building plus the flagpole. So here's kind of the building there. So multiply 100 on both sides. So 100 times the tangent of 39 degrees, 0.75 is equal to y. We go ahead and multiply them together. We find that y is going to be equal to 83.17 feet. But we said that this second picture is the building plus the flagpole. So in order to find the flagpole, we're going to subtract the height of the building plus the flagpole minus the building. So we have 83.17 minus 53.17 is equal to 30 feet. So the height of the flagpole is 30 feet. So the height is 30 feet for the flagpole. So let's look at the next one. From the time a small airplane is 100 feet high and 1,600 ground feet from its landing runway, the plane descends in a straight line to the runway. And we want to determine the plane's angle of descent. Okay, so let's draw a picture. So we have our airplane. It's going along, right? It's flying in a straight line horizontally. And so here's our airplane. And we know that it's 100 feet off the ground and 1,600 feet away from the runway. So the runway is like over here. And we see that we're going to know that the plane's going to be going down to hit the runway. And we see that this forms a right angle. Okay. The plane descended in a straight line, so the angle of descent is this angle right here. Okay. So we want to find what this angle is. So However, when we look at the triangle, this angle isn't on the triangle, but we know that these two are complementary to each other. So we can find this one because we have all the pieces for a right triangle. Okay. So we have theta, and what we want to do is we want to relate it to the two sides we have. So here we have an opposite side and an adjacent side. So we're going to relate it to our tangent function. So the tangent of theta is equal to 1600 over 100. So the tangent of theta is equal to 16. When I put this in my calculator, I'm going to leave it in degrees, so we're going to get an angle out in degrees. So in order to find what our angle is, we want to do our arctangent of 16, and that's going to be equal to theta. When we put it into the calculator, we find that theta is equal to 86.42 degrees. However, remember we said that the angle of descent is this angle right here, which is complementary to the angle that we just found. So in order to find the angle of descent, we said it's complementary, so 90 degrees minus 86.42 degrees. And that's going to give us 3.58 degrees. So we can round it. So the plane's angle of descent is about 3.6 degrees. The next thing what we're going to be looking at is directional bearings. So if we look at a bearing, the way it's read is, for example, this one here, it's 78 degrees east of north. So if we look here, we have north, and it's 78 degrees going to the east. This one here is 41 degrees east of south. Okay, so here's our south one. And it's 41 degrees going toward the east. The next one is 71 degrees west of north. So if we start at the north line, we're going 71 degrees to the west. Okay. So bearing on land and sea measures the acute angle. Notice they're all acute. The acute angle, the path or line of sight, makes with a fixed north and south line. So here, we're not starting like we typically start from kind of our north, our east and west. We're starting from north and south. So when we look at air navigation, a bearing is measured in degrees, and it's always clockwise. So we're going to be going clockwise, so this way from the north. So that's the way it's measured. Okay. Let's look at the last example. So we're going to be working with our bearings here. A plane is flying at 500 miles per hour, has a bearing of 48 degrees east of north. After flying 1.5 hours, how far north and how far east has the plane traveled from its point of departure? Okay, so we want to draw a picture and label all the given and unknown parts. The first thing I want to do is I want to draw the bearing here. Just to get a visual representation of how it looks. Okay, so we know it's 48 degrees east. So remember, north, east, south, west. So it's going to be 48 degrees east of north. So here's north. So we're going to go 48 degrees this way. So right here is 48 degrees. And we're going east, so that's why it's kind of in the first quadrant. Okay, so let me actually draw this to the side here so we have a bigger picture with it. Okay, so here we have our axis, and this is where the plane is actually flying, so it's going this way. And we know that the plane is flying at 500 miles per hour, and it flies for 1.5 hours. So we're going to see how far it flies after those 1.5 hours. So 500 miles per hour times 1.5 hours, and that's going to give us 750 miles. So we know that's going to fly 750 miles in those 1.5 hours. Okay, and we know that our bearing is 48 degrees. Okay. And the question asks how far north. So what we want to do is we want to find this right here, and how far east this right here has the plane traveled from its point of departure. Okay, so we know that this makes a right triangle. So we want to relate x and y to our 750. Our triangle is kind of flipped, so the 750 is our hypotenuse. Okay, so let's go ahead and look at x and y. So if we relate our x and 750, we know that 750 is the hypotenuse, and then in this case our 48 is going to be related to the x by the cosine, because that's the adjacent side. Okay, and the x is going to tell you how far north. Okay, so we said the cosine is relating our x and our 750, and that's going to tell us, the answer is going to tell us how far north we go. So the cosine of 48 degrees is equal to our adjacent x over our hypotenuse, which is 750. In order to find x, we want to multiply both sides by 750. And then remember, this is degrees, so make sure your calculator is in degree mode. So we're going to multiply it out. So when I multiply it out, I get 501.82. 84. Okay. And that's going to give me the distance that the plane traveled north in feet. Okay. And now what we want to do is we want to find the distance it travels east. Okay, so that's going to be with our y. So we want to see how y and 750 relate. The trig function that relates them is our sine. So the sine of 48 degrees is going to be equal to our opposite, which is y, over our hypotenuse, which is 750. Solve for y, multiply both sides by 750. 750 times the sine of 48 degrees is equal to y. Multiply it out, and we find that y is going to be 557.36 feet. So what we want to do now is we want to just kind of write it out in a sentence. So the plane traveled 500, we'll round this, 502, maybe let's say about 502 feet north, and about 557 feet east.